in the room than the rest of the week, but given that we're getting it on video, so this is going to go down in perenniety, so to speak.
Not doing a skit.
No, we're not doing any skits. You can Google that out. All right, so I have the chance to work with a tremendous amount of people all over the world, and it's been a tremendous privilege to work with Zach here. And nobody's asked me to do this, but in the name of the entire open source community, I wanted to thank you for everything that you've done for Android at Linaro and for the community in general. And please, let's give a warm round of applause to Zach here.
Thanks.
All right. Okay, so now, in this last session that we have, what we're going to do is talk about the actual Android framework. All right, that's what sits on top of everything that we've seen throughout the week. Okay, so who's got any sort of Java programming experience here? A few people. All right. So one of the key things that happens as you start kind of going up the stack, all right, your familiarity with Java has to increase because you start actually doing more abstract stuff. And it really is interesting what they've been able to achieve by mixing low-level things in Android with the Java stuff that they are creating. Okay? So, not much more about myself. You can go view the other videos. The only thing I'm going to say here is that I actually sent the last stuff to O'Reilly, so that book should be going to print any moment now. Alrighty. Okay, the framework. When I'm talking about the framework here, and you go back to the diagram I had on Monday, if I can rapidly bring this up, I just want to bring this back into focus. So here we have the presentation for that thing here, okay? So going up, back to this, okay? So the framework is all the yellow stuff that we see here. Alrighty? How does this thing come up? What does it do? And what can we do in order to change the way it works? So there are a few core building blocks to this before it actually kind of comes up. So there's the service manager. The service manager, if you remember the discussion on Monday, is essentially the user space component that attaches to the binder driver and acts as a yellow pages of all the system services that are running in the system. This thing comes up almost, as being one of the first native daemons that runs, okay? And it is required for all the rest to get going. Then you have the Dalvik virtual machine. That's the Java bytecode interpreter. You have the Android runtime. That actually took me quite a lot of time to understand what exactly it is. But here's the thing. So the Java code that runs in Android at some point, sometimes has to actually talk to native code. All right? And the API they have for developers, okay, is yes in Java, and most of it's encoded in Java, but it sometimes has to talk to some C parts. And essentially the runtime is those parts that the Java classes will access when they do native things. So you have that for a lot of the different pieces of the Java API where you have C stuff that has to be called. So the Dalvik virtual machine by itself is good for interpreting Java bytecode, but it's not specifically meant to run Android code. However, when you load the runtime into it, which is essentially a .so, a library, then it can actually run Java bytecode. For Android. That's what I'm, essentially Android, Java bytecode. And then you have the Zygote. That's the first Java process that starts and essentially preloads or warms up the RAM with all the classes that an application could possibly need. So these are the things that you need there prior to all the rest of the things kind of starting up. So then the next thing that comes up, of course, is the system services. So you have, as I said, the system server, which houses most of the Java-based, all the Java-based system services. You have C services, which are in there, namely presently just the sensor service. Previously in Gingerbread, there was also the Surface Flinger. In Jelly Bean, it's now a separate process. You have the media service, which has a bunch of system services, and then you have the phone application, which is a special application, as I had said, that is marked as being persistent and therefore is not lifecycle managed, and it is actually housing a system service. There's only one other example such as this that I know. It's the NFC application. It is also marked as persistent in order to allow it to run the NFC service. All right? One of the things that comes up as part of those system services, so whenever, for example, after the surface flinger starts, it uses one of the init commands to tell the init to start the boot animation. And the boot animation, essentially there's two kinds of boot animations. There's the default one with the Android logo and letters with the light shining and reflecting on that. And the other one is essentially a bunch of PNG files that are made to be executed based on the content of this boot animation.zip. All right. If you go on the web and you look, for example, at CyanogenMod, they have a bunch of these boot animation zip files. Just extract and look at what's inside. It's a whole bunch of PNGs with a TXT file that tells the system how to actually run these PNGs. And so when the animation comes up, it's just cycling through PNGs, essentially. If you don't want the boot animation, you can do setprop debug sf no boot animation 1, and that will essentially gonna shut down the boot animation. Now, one of the things that happens at startup is that the system goes through the file system and finds all the jar and APKs and does DEX optimization on them. Remember, Dalvik has just-in-time compile, and what this is that it is actually taking all those Java files and making native copies of them so that Dalvik can actually execute that instead of interpreting bytecode. So it finds all the jar files, APKs in the system, creates those DEX files, these DEX files out of them, and then those DEX files are actually what gets run by Dalvik. So these are all the places where this stuff is looked for. And if you don't want this to be done at boot time, because it's just going to eat up CPU cycles, or just make it slow for the user, then you can actually compile the AOSP and tell it with pre-optimized DEX files. And in that case, what happens is at build time, it will generate .o DEX files in the same location, all the APKs and jars. And at runtime, at boot time, it won't need to actually do any DEX optimization. All right. Now, once that's done, the next thing that happens at boot up is essentially the apps that are started up automatically. So you have input methods which are initialized, persistent applications. So for example, the phone application will start automatically like this. You'll have the home screen that will start because the activity manager sends out an intent. You'll have the boot completed intent that is sent out, and that is essentially going to start a whole bunch of different things. And then the widgets that will start when the home screen is started up. All right. So for example, if I go to my shell, as I've been doing over the past few days, and I actually start the emulator, and all right, so where'd he go? Hey, where'd you go? All right, you went on the first screen for some reason. All right, send this out to the other screen. Now, if I shell into this, and I type PS, you see here all these COM, Android, whatever. These are actually applications. And I didn't do anything, right? As a user, I didn't actually activate any of this stuff. It started because essentially a lot of this is tied to what I was showing you in my slide here, which is they're responding to some of these things. They're either persistent, they respond to the boot completed method, or the app widget stuff. Okay, once the system is started up, what can I do with the framework? How can I interact with it? So there's a bunch of commands on the command line that allow you to interact with it and do different things. So for example, I can do something like service list. This is going to list me all the system services which are running in the system. And service is actually quite a powerful command line tool. Let me show you. So let me unlock this, force it to be on the top. All right, and let's do something like that. And I'll explain to you what I do afterwards. Service call status bar 1, right? The status bar has expanded itself. And let's actually collapse it. Status bar 2, it collapses. Okay, so expand, collapse, expand, expand, collapse. What am I doing here? Okay, so the service command line tool over here is actually talking over binder directly to the status bar manager. Status bar manager essentially is a system service with which the status bar application will register itself when it starts. It registers with the system service and gives it an interface so the system service can talk back to it. And then when you're doing this service call, you're actually talking to that status bar manager, which is then interacting with the status bar to do whatever you're asking it to do. So on the command line here, I can use this service call to call on almost any system service I want. Of course, the parameter list is a little bit more involved here, so let me show you. Okay. So here I did service call, I gave it the service name and a code, but of course there are calls that you make that will require parameters, and you can actually pass those parameters along on the command line. In this case, there's no parameters, and just task me afterwards and I'll show you the actual code. The number I'm putting the code here is actually the sequence number of the call in the AIDL file that declares that system services interface. Alrighty, so let's actually not put this on top anymore and go back to this. Then you got dumpsys. Dumpsys is also very interesting, so I can do something like dump. Let me actually shell out. So no, that's not what I wanted. 2 seconds and I will be back where I was. That, 2, 3, 7, 1303. Okay, so dumpsys starts off by listing all the system services, and then it actually goes out and asks every system service for its status. So here we are dumping the internal structures of every one of those system services. Of course, it's a tremendous amount of information, and it is information that is only interesting if you actually understand how that system service works internally. But it is very useful if you do implement your own system service to have one of those dump functions, because it will allow you to poke your own system service and see where it's at and whatever it's seeing with regards to the state of the system. And another one that's in there is this dump state. So I can do dump state. And this actually goes out and fetches information in /proc. It fetches this dumpsys. It fetches logcat, a whole bunch of stuff, and kind of gives you a dump of the state of the machine. Okay? And you can get this same information on any commercial phone by typing bug report, which is an unprivileged command. Okay? So if you plug any handset on your laptop, you type bug report, you'll get all this information, which is actually pretty useful if you want to debug a device in the field. You have raw backup, which will essentially copy the content of /data. And then you have some service-specific utilities. Okay? So for example, you have AM. AM will allow you to talk to the activity manager. This is the thing that manages applications and all the rest of the stuff. So let me actually show you an example. If I can remember where I put this. Star /LTT cat to sort 2012, 12 and 17. Instructions. Nope. No. There we go. So, copy. Let's see. Actually, let me bring this, keep it on the foreground, and do that. So I'm sending an intent on the command line to tell the system to go actually to a web page. Right? If you need to shoot any intents on the command line, this is very, very, very useful. So instead of actually crafting an application that shoots the intents, you can script it on the command line. Of course, there's a lot more to AM that I'm showing you here. And another one is PM. PM will allow you to talk to the package manager, which is for managing the installed apps and installing new applications, removing applications, and that kind of stuff. There's also SVC, so I can type SVC and essentially control the power, control the data, and there's a whole bunch of other ones also in addition to what I'm showing you here. So let me actually get this guy out of the way. So there's SVC, there's IME, which controls the input methods. There's input for sending input events. There's Monkey. Monkey is a very interesting one because Monkey, if you look up the app developer documentation, it tells you that it allows you to send random input to your app, kind of like to test. However, there's a mode for Monkey where you can actually give it a script, and that's not actually in the app developer documentation. So just bug me about it or send me an email if you want, and I'll send you a sample script. I have one around here. Let me see if I can actually make it work for you. 2, 3, 4. Where did I put that? No? No, I'm not going to remember. But essentially, you can actually tell it to do specifically, touch this button and, send this message to system service and that kind of stuff. Very, very useful in a specific order. And then you can script that, of course, if you want to test your interface. There's stage fright for actually talking to the stage fright media layer if you want to kind of force it to play back stuff. Now, the interesting thing about these, and this is really, really cool. So let me actually show you this. If I take the sources out for the AM command, for example. Okay, that thing I typed on the command line. So frameworks, base, commands, AM. Now, if you actually look at the command, actually let me show you on the device. ADB shell, cat, system, bin, AM. It's a script. All right. What is it actually doing? It's actually running this thing called app_process, which is a native C command line utility, right? And app process starts a Dalvik virtual machine and then actually runs some Java code. And if you actually look at the code for the AM command, it's a Java file. If I go to src com android commands am, here's am.java. And if I scroll down, we shall see the actual help screen that we saw earlier when we just typed plain am. There we go. Here's the help. And all the parsing of this goes on here. What does that mean? That means that you can actually write command line Java stuff, which talks to the framework. Okay, this is really powerful. So if you need to directly talk to the classes and whatever APIs that Android is exposing, you can do that on the command line. Now, that doesn't mean that you can actually start an app from the command line. That's different. But if you want to talk to a system service and kind of use the same data structures and classes, you can do that. AM does it, PM does it, a whole bunch of other commands that I showed you actually do exactly just this. All right. Then if you actually want to start a Dalvik virtual machine directly on the command line, you can use Dalvik VM. But nobody almost uses that, or even DVZ to start from the Zygote. You're either using AM or you're using app process. These are the two common ones which are very often used. You have dexdump, which will allow you to essentially kind of disassemble dex files if you're interested in that kind of stuff. Okay, native daemons. So remember in my architecture diagram here, I said there's a bunch of native daemons which are running over here. Now the thing is, the system services are mostly housed in processes which are relatively unprivileged. They run either a system or some other user which doesn't actually have root access or things like that. So for example, if you want to install a new app, remember where every app has a user, and therefore you have to create that user and you have to set the proper directory permissions. Well, you kind of have to be root to do that. All right? System server can't do it, and therefore there is a native daemon that does that for it, and it's called install-d. So there's a whole bunch of these native commands or daemons that are actually very useful. So the service manager, as I said, that's the context manager for Binder. The sources of that are in frameworks-based CMDs, and in the file system at runtime, you'll find them in system bin. Okay? And if I go and type PS, you will see that I have my service manager running somewhere around here. PS, we have service manager. Okay? And these other daemons I'm talking about, vald, netd, reald, installed, keystore, and there's a whole bunch of those. So let me actually detail you what those, what these are doing. So installed is actually kind of like the daemon that the package manager service uses. Remember, there's the PM command I showed you 2 minutes ago that allows me to talk to the package manager. The package manager itself can't operate on the file system. This is what does it. This is what does the job for it. It is running, at least in Gingerbread, as root. In Jelly Bean, it's running as install, and it will actually do the creation of the directories and setting the permissions and that kind of stuff and doing dex optimization. vald. All right. So one thing. You can't actually talk to the service manager yourself. Well, you can. You are by typing service, right? But there's nothing more for you to do. You can't actually tell the service manager to add a system service just on the command line. You actually have to run something that tells it add system service. Installed is something you can't actually talk to on the command line, so to speak. But vald is. There's a tool called VDC that allows you to talk to it. vald is essentially the counterpart to the mount service. Okay, mounting, formatting is things that root can do. The mount system service in Java is not running as root, can't do those things. The vald daemon does that for it. Okay, and you can talk to that by typing VDC. All right, so I can do something like VDC volume list or VDC dump. Okay, but if you type VDC alone, you don't actually know what the commands are. All right, so how do I know those? Because I know how to read C. So if you go to the sources and you go up to system, vald, you go to command listener.cpp. This file here is the wire protocol between VDC and vald, and it's the same wire protocol that's used by the mount service, and it's essentially string based. So if I can scroll down here, you'll see something like, for example, the volume commands. So it parses and says, oh, he wants to run list, right? Or he wants to run mount, or he wants to run, whatever, share or format. All right? So if you want to understand what the command line is for these tools, look this file up, commandlistener.cpp. Alrighty. netd, same thing, takes care of the networking for the network manager, and it also has a ndc command like the VDC one. So I can type ndc interface list, all right? Lists the networking interfaces that it recognizes. reald takes care of the radio, talking to the baseband processor, and there's actually a command that talks to this. I think it's radio options. That's the command that actually talks to this. So again, same kind of configuration where you have a Java service talking to this, which is actually talking to something else. There's also the key store. This essentially is for, apparently, and as far as you can see in the sources, for storing crypto keys. So essentially, for if you need a SSL cert to access a network access point, this is where the key will be stored. There's a daemon running in the background that actually takes care of that. All right, which gets me to the internals of the system services. Any questions so far? I've been moving relatively fast here this morning, as the other mornings. Yes, sir. I'm sorry, does reald talk to the Wi-Fi stuff? No, the reald stuff is really for the baseband processor. The Wi-Fi functionality has the WP supplicant, and there's a library to talk to the WP supplicant, which is used by the actual Wi-Fi service and all that kind of stuff.
Which is actually all hidden under the connection service.
Yeah, the networking stack is fairly, beefed up in Android. If you actually want to get some insight on the networking side of things, there's a presentation by Benjamin Zoris at Android Builder Summit 2 weeks ago. The slides are on the web. He added Ethernet support in the stack, and when he had to do that, he actually had to disassemble, so to speak, the stack on the networking side, and so he gives a good diagram of what that does and how it works. Okay. So now that we've kind of discussed all the plumbing underneath the stuff, the meat here is what is in here, how does it work, and how can we start, figuring it out. So there's a whole bunch of system services that are running in the system. You can type service list to find what those are. This list here is from Gingerbread. It has about 50 items inside of it. There's about 70 of them now in Jelly Bean. If you just kind of want to have some insight here as to what you're attacking, there's about, at least in Gingerbread, about 3.5 megabytes of sources in there. Almost 20-25% of that is the activity manager. So it's a pretty big chunk of the system. All right. Of course, this has grown, and oftentimes a lot. Since then, some of the system services which were coded as a single Java file now actually have a full directory dedicated to them with a bunch of Java files, such as the example of the Power Manager and a couple of different other things. If you want to observe these things at runtime, so if I go on the shell here and I type PS, I can actually spot the PID for the system servers. So in this case, the system server's PID is 61. Okay? If I type logcat, it will give me all of the stuff of all the processes, all the output for all the processes, but I can do something like this. I can do adb logcat grep, say 61 close parenthesis, close quote. And here is the output that is specific to the system services. All right, so this is just going to be the log information that the system services have printed out. Let me actually there's also dumpsys, and I showed you dumpsys a while ago. So you just type dumpsys, gives you a list of system services, and the dump of that system, all the system services as state. So an app developer, when he's talking to system service, the way he calls it in Java is he does get system service, get visit a string, gets an object, and then does object dot method. Right? So from the perspective of an app developer, he's just talking to a regular object. As we'll see, there's actually a lot of plumbing underneath this. Okay? So if you want to check inside system services, you're going to have to arm yourself with a bunch of different tools. So there are reverse engineering tools out there commercially available that will kind of take sources and try to show you call graphs and block diagrams and that kind of stuff. The results with Android may vary. The Android code base is fairly large, and some of these tools have a hard time kind of absorbing Android. But let me actually show you one thing I've done myself. So I went essentially in included Eclipse. So let me say Eclipse. I put Eclipse in the loop, so to speak, and because Eclipse is pretty good at actually, giving you parsing Java and giving you kind of like ways of browsing around Java. I apologize, Eclipse is not the fastest thing to start, but so what I did is I actually went into Eclipse and I kind of imported all the sources of the system services, and once that was done, I opened. So I can open, say, for example, here the activity manager, and if I go at the end of this, right?
That's way too bloated. That's the reason why I use VI.
There you go. All right, activity manager. Okay, so pop this out, and if you go to the bottom of this file, all right, Control End, you can see here it's got 500 lines. 12,500 lines. Sorry. Okay, it's a pretty large Java file, and that's Gingerbread, of course. And you can scroll up this thing, and of course, there's a tremendous amount of code here, and it's really hard to tell things apart. But here's a cool thing you can do, for example, in Eclipse. I can go here, I can do folding, and then collapse all, and all of a sudden, it actually is a little bit more readable. Okay, so they've kind of categorized every set of calls per type. And my bet is whoever's maintaining this at Google, aside from guaranteeing himself a job forever, is actually writing the code in this fashion. All right? Okay, So just to give you an idea here of a few system services, the activity manager manages everything that has to do with activity. So for example, when you start an activity, for example, from the launcher will talk to the activity manager through binder, tell it to start activity. And then the activity manager will turn around and talk to the zygote through socket and tell the zygote, please fork and run this Java class. And that's exactly what happens here. Package manager takes care of, as I said, installing the APKs and resolving intents. When you shoot out an intent and say, for example, I want to view a PDF, this will find a PDF viewer for you. Window manager takes care of the layering of things, the Z order and the positioning of things in the screen. Notification manager takes care of the toast messages and the display of things on the status bar. So it sends out, show this icon, there's a new email or whatever. Power manager takes care of the wake clock mechanism and the LCD stuff. Network manager takes care of the tethering. There's a Wi-Fi service completely separate from this. You got the mount service, which takes care of the mounting and unmounting of stuff. Location manager to find out where you are. Status bar manager, which I showed you earlier, and the list goes on and on and on and on and on and on. Okay? 10 minutes. Holy cow. Let's see what we can do in 10 minutes. So how do you create or see what a system service does? So here is a 5-minute try to get you to see and understand what happens when a system service gets called. So if I go to services, Java, com, Android, server, I look at what the power manager is doing. So the power manager here, okay, is a Java class. And it is essentially extending this iPowerManager.stub. If you're familiar with Java, this is inheritance, and it's inheriting from a class. And at this point, you'd probably be wondering, why is he showing us the class without showing us the parent? Skip that for a second, I'll come back to it. So the constructor for this class, where is it? We have, let me actually look for it. All right, Power Manager service. Here's my Power Manager service, and essentially over here it is going to instantiate itself, and then we'll be able to start talking to this system service. So for example, in this, do we have the initialization part? Sorry, where does that? There. So the initialization part of the system service essentially does something like native init, and if we look that up, native init, it is declared as private native. What does that mean? Does anybody have any idea? JNI, right? It's talking to some C underneath it. Okay? So this Java system service here, which is the core of the intelligence of the power management, has a counterpart which is in C. Okay? To talk to this system service, you need an interface definition. That's the class from which this class derives. That's the parent class. So to find that out, you won't find the iPowerManager class, which I was showing you here, in the sources. You won't find this, the iPowerManager.stub. What you'll find is an AIDL file called iPowerManager. Right? So if I go out here, go back in my sources, go to core, Java, Android, OS, there is a iPowerManager.aidl. Here is the interface definition for this system service. This is how you talk to this system service. All right? And if you go to the status bar, which is not here, it's inside, I think it's inside view, but I could be wrong. No, I can't remember. Anyway, if you would look at the status bar one, you would see that the expand and collapse are number 1 and number 2. Pretty much like I had done when I typed it on the command line. All right? So that's for the interface of the class itself with its C counterpart. Right? So let me actually take another system service and walk you through what happens from that system service all the way down to the hardware. Okay? In 5 minutes. Let's go with the light service. All right? The light service is pretty straightforward. It takes care of all DAS blinking lights on the system. So that's the LCD backlight, the blinking lights that tell you got a new email or whatever else. All right? The constructor for this guy has got, much like the other one, all right, a init native, okay, which is a native C. So the C side is inside JNI here, com Android Light Service. Okay. Here is my init native. It's talking to the HAL to tell it to get a SO. Right? And if you go back to my diagrams, just kind of like to fit all this stuff together. Forward up to this guy here. So we have the system service, the light service here in Java. It's C counterpart talking to the HAL, getting this SO, and it can then talk to that SO. Alrighty? So, what is the definition for the interface between the C side here of the system service and the SO? What's the contract, the API that the SO has to provide for the system service to be able to talk to it? That's in the hardware directory. So if I go here into hardware, lib hardware, include hardware, there's a lights.h, and the contract is right over here. It's the structure that says set light, and these are the parameters to set light. So this is how that system service talks to the SO. That's the protocol between these two things. So long as the SO provides that, then the system service assumes it can talk to this hardware. Fine? Now, there's a few different things here that are of interest. So let me show you. If you go to the init native here definition in Java, it says it takes no parameters. If you look up the C init native, it takes 2 parameters. Okay, this is the case in every single JNI call that you will see around. There's the object being passed and the actual handle to the virtual machine. This is really useful. Because in some cases, you actually have to tell the virtual machine to give you a real C object to operate on because the virtual object is of no use to you. If you get an array, for example, it's a virtual array. There's no way for you to do anything with that until you tell the virtual machine, give me a C array. And then it gives you a C array, you do what you want, and then you give it back. You say, OK, I'm done, that's it. And it actually transferred back to the Java language. Okay? There's a whole lot of Java stuff going on here, which JNI stuff that I have to kind of skip. But you kind of get the idea. All right, so if you actually want to wander around my slides, you'll find an example system service that I added. Actually, I have a blog post about that, so you can actually follow the code and do it yourself if you really want to. Which gets me to the framework. So there's a whole bunch of customization you can do to the framework. And let me actually try to pull one off very, very quick here before we actually end. So let's say, where's my emulator here? All right. Here's my emulator. As you can see here, it's got a phone signal meter, right? Your device is probably not a phone, or maybe not a phone, so what do we do, right? Well, we got to go and actually tell it not to display a phone signal. So how do we do that? Let's go in the code of the status bar. So packages, system UI, srccom, Android system UI status bar policy, and let's go looking for phone_signal. Okay? So here is the method call that tells the status bar to display that phone signal. I can do something like this. I can do, so let me just find another instance and copy it off. mservice.setIcon visibility. Here's one. Copy that off into my buffer, phone signal. Here, insert this guy, and it is phone signal that when you set to false. Now there's a bunch of these set icons because essentially what happens is phone signal. The status bar changes state, and when it changes state, it has to reset icons. Okay, so there's 4 instances in this file. Now that I go back to my command line, I can essentially rebuild this. And I'm going to keep the other VM running. And as soon as this is done building and I open back a new VM, you'll see the phone signal's gone from the status bar. Now, why do you need this to do this in sources? Because if you actually are familiar with the app development API, you know that what's on the right-hand side of the status bar is not something you can touch. You can actually add icons on the left-hand side to say there's a new email, there's a new tweet, there's a new this, that, but you can't actually change what's on the right-hand side. To do that, you actually have to go to the sources. Right? So we're going to let this run in the background. I'm going to finish the slide set and come back to it. So remember, I told you that when you actually talk to a system service, the way you do it is with something like this. You do get system service. But with what I showed you earlier, or what I show you here in the slides for adding a new system service, if you want to talk to it, you actually have to do service manager, get service, give it a string, you get an interface, you cast that into an object, and then you actually call it. So it's kind of like convoluted, all right? The way system services are provided to app developers, they're wrapped a little bit further. And to do that, there's a bunch of files they need to change, including that get system service implementation, which is over here in app context impl. And when you extend that, then you can actually plug into the standard API app developers have access to. All right? And you can just grab the snippets over here. And this is the status bar hack that I showed you. There's a whole bunch of things in the stack, like default networking, default browser, bookmarks, and that kind of stuff. And you can change all of that if you want to. And let me actually go in here and start the new emulator. Where's the other guy? There it is. So as soon as this guy comes up and shows me the home screen, I should essentially have myself a Android that doesn't have a phone signal. Of course, you may have other stuff to add or remove from that, but that's a basic kind of hack. There we go. Gone it is. Questions? Yes, sir.
Is there a way to tell how the Android home screen, when the Android home screen comes up by looking at command line?
Is there a way from the command line to know when the home screen is up? What you can do is hook yourself into the app widget stuff and the boot completed stuff, intents, and then from there, launch your tests if you want. Because these are the intents that apps themselves would get to tell them they can start. And they can only do that when this is up and running. Other questions? I think we're done.
Thanks, Karim. Appreciate it.
Well, thank you all. I hope you've enjoyed these 4 sessions. And I'll be around till the end of the day if you have any questions or anything like that, or want to have more information about any of the stuff that I've talked about.
Yeah, so just before everybody turns into a pumpkin, so Karim actually has a much more expanded version of all of the sessions he's actually done that he offers to companies and people that are interested in finding out more about his work, and he'll come on site and do all this stuff. So if you're interested in having him come to your site, please just let him know.
Thank you, sir. All righty. So enjoy and see you guys later.